Very good morning to all of you. Today we are at lecture 1 of Power Electronics EI 604A. Right now, this is very much interesting subject for you that has chosen, that is power electronics. In that part, you will get so many devices along with. Mainly, you will use SCR as well as the power diode for certain application. SCR means silicon control rectifier. In basic electronics, you have already done that part. A few part that is the transistor and FET, and there will be a modified transistor and FET also here available in this power electronics. Now, before going to the subject matter, what is basically the COPOs and COs that we will observe? Okay, now move forward. So it is the topic today is here the introduction to the power electronics. So now the subject name is basically your power electronics. While the subject name is your power electronics and subject code EI60, actually it will be mistaken EI604A. That is EI604A. Okay. So it will be EI604A code has mistakenly put. And we have here 36 lecture. So obviously we have to cover up all the syllabus. Now go through the syllabus first. Okay. As fast as possible. So go through the syllabus. And let's move forward. And we are going to the syllabus. So let's move forward. So what is the syllabus we have? That is basically the prerequisite we require analog electronics as well as the concept of the circuit theory and the basic electronics and the course objectives. These are four course objectives you can go through. Okay, to understand the constructional features and the characteristics of the power semiconductor devices, including the power diode, power MOSFET, okay, UJT, and you have the ACR, all the other devices. Then to understand the working principle in switching operation of the different semiconductor VSD devices and to prepare the student to analyze and design different power converter circuit and to implement the different power supply modules. Okay. Now there will be the four course outcome depending on the module we have that is we have the four COs CO1, CO2, CO3 and CO4 you can go through. Then we will move forward. So what are the reference book we need to follow? The reference book we need to follow here, that is basically very much user friendly or student friendly book, that is PS Bhimra. Power Electronics, there is a Khanna Publishers book, and we have Precision Power Electronics of Tata McGraw-Hill, New Delhi, and we have Image Rosit also in our library. So you can collect any one of the books or you can collect personally PS Bhimra, that will be helpful for understanding the power electronics better. Okay, now we will move forward. So what is basically power electronics? Why it is so called power? That means all the power devices are incorporated with. Why it is so called power? Okay, let's see. Power electronics means basically it will provide high voltage rating as well as high current rating, right? So the arrangement within the device will be such that we will get the high voltage as well as the high current. Okay, then we will obtain the high power from those devices. We will obtain the high power from the devices. Now, suppose as per the examples, suppose we have here we have certain kind of devices, suppose your MOSFET or transistors. Okay, so here what we have here, certain rating will be there, right, for each of the devices. For each of the devices having their voltage rating fixed as well as current rating fixed. Now, how to enhance why it is called term power. That means you are enhancing the power rating of the device. So how to enhance? This is the question. how it will be obtained. Now see, while we are configuring all those power devices, or we are fabricating all those power devices, so it is very observable issue is that while we have to enhance the voltage rating, so many devices, the same devices we have to put in series, right? So the devices will come in series. If we connect in series, if we put fabricated all those devices in series, as well as to enhance the current, to enhance the current rating. So what do you have to do? All those devices will have to connect devices. We need to connect in series, right? That means, let me clear my all this page and we will be taking a fresh page. Say, suppose it is a simple diode. Okay, now the current rating of the diode is suppose 300 milliamps. Okay, or 1 amps suppose, and the voltage rating what we have generally, if it is in forward blocking mode, then it will consume basically 0.7 volt. If it is in a reverse bias region, then it will consume basically this that characteristics, VI characteristics. What will get after knee voltage? There will be the exponential rising current, and that knee voltage is 0.7 volt. And again, in the reverse region, before breakdown, there is a few amount of current, so we can neglect it. It is the off condition of the device, it is on condition of the device. So while the device is on, it is consuming zero point 0.7 volt. Now you have to enhance the voltage rating. So how could you put here? If you put so many diodes in series, so ultimately what will get zero point 0.7 consumption, zero point 0.7 consumption, zero point 0.7 consumption. So you are getting here zero point 0.7 into 3, that is volt. That means we are enhancing in this way the voltage. Or there is a specified configuration we will get. There will be a specified configuration that is called the drift region. We will get that through this drift region. Basically, we can enhance. This will be mainly n minus layer. Okay, we will find in our device configuration. So that will enhance the voltage blocking property. Voltage blocking property. Similarly, whenever we have to enhance the current rating, when we have to enhance the current rating, so what do you have to do? All those diodes that may be connected in parallel, such that through the parallel path we are getting the equal amount of current from each diode. So we will be getting the current that will be triple times of I if I is the flow through a single branch. So we are getting triple times of the current to enhance the current rating. So we can put in parallel. So there will be so many devices that will be connected in parallel to get the current rating to be high. Current rating to be high. Similarly, for the voltage enhancement, we require so many devices that will be connected in series. Okay, so like this way, the as well as there will be certain regions that will enhance uh, the blocking voltage blocking property of the device. And ultimately, what is the objective? The objective is we need to enhance the power. Ultimately, the power. Okay. So this is basically the steps. These are basically mainly steps we will find whenever we will go through the construction of those different devices. We will get that the enhancement of voltage as well as the current that will be done through in this manner. Okay. So let me clear my sketch, and then suppose we have here another important issue is what is the utility or application of this subject. It's a versatile application. Now see, while we are controlling a huge to control a huge motor, suppose, or generator, okay, or any rotating shaft. There will be error involving with the rotating shaft or motor having certain amount of field current. Okay, so that's why where we are controlling basically some amount of field current or amount of voltage, so we require basically the control element to be incorporated. Control element means in terms of devices over here. Suppose as per example, we mainly use here. This is the elaborate application of SCR, that is called silicon controlled rectifier. Silicon controlled rectifier. So in this silicon controlled rectifier, what is the basic difference with a normal rectifier? In case of normal rectifier, if we find, we will get that there's a normal rectifier, and we will get that the input output waveform, if we draw V in versus omega t, whereas it is V output versus omega t. So what we find, this will be the V omega t sinusoid we are putting here. If it is full wave rectified output, we will be getting this kind of waveform. So it is called mainly uncontrolled rectification. So whenever we have to control this rectification, that is control that means the average value is fixed. What you can say, DC or the average value, V average versus T, that is fixed. And while we are talking about the controlled rectifier, so the waveform of input output, again I am sketching for the controlled rectifier. So what we obtain in case of the controlled rectifier, we will obtain mainly the output will be, if it is full control, then we will get this kind of output. Fine. Okay, so we will get certain part of the cycle, AC cycle, that has shifted off. So certain part of AC cycle, it is the load flow, if I say versus omega t or VL versus omega t. So what we'll get? We will get certain part scripted off. Certain part is scripted off. While omega t equals to alpha, we are getting here the device will on, and then it will continue. Then again after certain angle, the device will on. So here in this manner, if we can control this angle, if we can control, then ultimately we are controlling basically the average value. So VTC or V average versus T, we can control. Now if the cycle that we are passing basically through the load, that is very smaller amount, so we are getting less amount of DC. So in this way we are controlling basically the voltage. Now in case of the motor, so suppose we have to control the field current or the field voltage. So in that case we can provide this control element over there. So, and in another application we can find here the drives. So drives actually require whenever suppose you are you have experimented with, I think, relay drive frequently. So in that case it is requiring with a particular amount of voltage rating as well as the power rating. So how it could be done? So this relay is operating with a very smaller amount of voltage, DC voltage, suppose it is 6 volt relay or 7 volt relay, and it is driving the motor. So obviously there should be the driver network. That driver will basically provide basically the boosting of current, boosting of current or the voltage. That will be done through the driver network, mainly the current. Then the relay can drive basically a particular motor or the generator. So in the drive, it is a huge subject where we will get the application of all those power electronics devices. So drives is mainly a part of the power electronics over here we will go through. Okay, now so this is, I think, all about the introduction of the power electronics. I can give you that idea where we are enhancing mainly the power rating of the device. Okay, we are enhancing the power rating of the device. We want to get the high power rating. That is our objective. So that will be accomplished as because D into I. So the voltage rating that should be high as well as the current rating that should be very high. So in this way we will be getting the power rating will be high. So we have to arrange the device like this way that the voltage rating as well as the current rating that we will get high. Okay. So I think it is the introduction over. So almost all in our syllabus, we will go through the power diodes and the power transistor, power MOSFET and the SCR and their families and several application of the SCS we will find along with the power diode or power transistor sometimes. Okay. So thank you for today.